Welcome to the CEC Gurukul lecture series. I am Dr. Anuradha from Lady Shri Ram College for Women, University of Delhi. Today I am going to start the first lecture on the descriptive statistics, and subsequently possibly I can add few more lectures so that you can, by the end of the lecture series, you will be able to get the idea about the subject. Now, before going on to the descriptive statistics, I think I would first like to little bit talk about the discipline, which is statistics. Now, believe it or not, in our day-to-day life, we use statistics without actually realizing it. I am sure most of you must be getting up in the morning or during the daytime, just going to the Google and searching some information on restaurants near you, information on new products which are coming online, new brand of mobile phones which are coming online, and you want to have detailed information about them. To do that, to search that option, what Google is doing is it is using a series of complicated and very extensive statistical methods to actually come to an option, or to actually predict an option which is most closest to your search area. Let me add one or two more examples to illustrate the applications of this subject. We are aware that when the elections are about to happen in a states or national elections, there is an exit poll that happens. But the agency which is doing the exit polls is always collecting data on thousands of voters, and then it is summarizing that data, it is analyzing the data, and then they interpret the data and end up predicting the seats, what the number of seats that the party is going to get in the elections. One more example, which is our day-to-day experience that happens, is that if we are going out to visit some place and we want to check out, okay, what is the weather going to be there, is it going to be cold, is it going to be hot? So for the weather prediction or weather forecast, again a very diverse data is collected from various sources, and they are used, or rather they are a statistical model is run over this data, and then they come out with fabulous predictions, very good predictions. So prediction in terms of the expected date of the onset of the monsoon, or the average rainfall that we are going to have in a particular region in the coming months. And in fact, day-to-day weather forecast for 15 days, 20 days, and all that is possible because of statistics. So statistics is a discipline which has deep-rooted applications in diverse different areas. Wherever you have data, the application of statistics is compulsorily used. We cannot, analyze data without using statistics. So let me just start by now defining the statistics more formally. Statistics is a discipline that applies various tools and techniques to process raw data and ultimately results in meaningful conclusions. Now, meaningful conclusion is the most important part. It is when the data is in front of us, we cannot make any headway about what the data is talking about. But then the tools are there in statistics which, when we use them effectively, we are not able to look much deeper into the data, but we are able to get to some meaningful conclusions by studying that data. Then the statistical process includes collection of data, organization of data, summarization, interpretation, and reporting of information. So all this comes under statistics, and by studying this discipline, we end up studying the techniques to do all these. And statistics is very rightly called an art of reading data or an art of coding data. And statistics has a wide applications in various fields like finance, economics, biology, psychology, education. You name any field, and statistics is there to help you with the analysis of the data. Now, I will focus more on the descriptive statistics. There are two branches of statistics, this is descriptive statistics and inferential statistics. I am going to start the first lecture on the descriptive statistics. When I start studying descriptive statistics, the most important concept is that of variables. Variable is any characteristic, number or quantity that can be measured or counted. Variables can be further classified into two categories: qualitative variables and quantitative variables. Let me first highlight what is qualitative variables. As the name suggests, this data is going to measure the qualitative aspect of the variable. It takes values that are categorical in nature and cannot be quantified. Qualitative variables can be further broken into two categories. One is nominal variable and the other is ordinal variable. Nominal variable describes a name, label or category with no natural order. For example, the mobile number. We have to understand that mobile number, we are using the numerics 1 to 9, but the mobile number is like a label. So what I mean to say is, if there are two persons and they have mobile numbers which are different numbers, so if one mobile number is greater than the other mobile number, it does not mean that the former is a better mobile phone. Okay. So here although we are using the numbers 1 to 9, but they have to be treated like labels. They cannot, they are not measuring the through the numbers. And these type of data do not only assume the numbers as the labels or categories. We can also use like if I am looking at the preference of the teenagers of the dress color that they want to wear it to the party, then that variable is going to assume the values like blue, green, violet, indigo and so on. So here the property that holds for these variables is just the equivalence. That means what? It means that either the two values of the variables are same or they are unequal. They are equal or they are unequal. There is no other property, like we cannot add these values on the variables, you cannot multiply, you cannot divide, you cannot subtract. All those cannot be done on nominal variables. Then let us move on to this next type, which is ordinal variables. It describes labels or categories which are defined by an ordered relation between them. So what do I mean by an order? I will just explain it through an example. For example, CGPA scores obtained by students. The CGPA scores obtained by the students is generally on any number between 0 to 10. So the numbers can be 9.75, 8, 6, 7, 4.5 and so on and so forth. Here these CGPA scores are again labels, okay, but these labels can be arranged in an ascending or a descending order. What that means is there is a hierarchy between these numbers which was not present in the nominal variables. Here the hierarchy is present, so I can define, for instance, greater than and less than. So I can rank this type of data. Okay. So intuitively, if there is a student who has got CGPA score of 9 and there is another student who has got CGPA score of 4, then which student are you going to think is better? The first one. So the CGPA score, higher the CGPA score, better the student in terms of academic qualification. Not only the equivalence holds, but ordering also comes into the play when we define the ordinal variables. So we can actually rank this data. We cannot rank the nominal variable data, but we can rank the data on the ordinal variable. Next comes the second type of the variable that we will look into, which is quantitative variables. Names only suggest that these are the variables which measures the quantity. Okay. So a variable differing in quantity is called quantitative variable. These can be measured in interval scale or ratio scale. By and large, we must understand that the measurements which are coming or the data which is coming on quantitative variables can be added, subtracted, divided and multiplied. And in fact they can also be arranged in an ascending or descending order. There is an equivalence also which is present among these variables. So these variables are little bit easier to handle because all the mathematical operations can be done on these variables. Let me put a stress on one point here, that when we do the study of the qualitative type of variable, then we have to use some special techniques in statistics to deal with such variables, because as I told you, those algebraic operators like plus, minus, division, multiplication are not applicable to those variables, whereas in quantitative variables we are in a comfortable zone and we can use those operations very effectively, so there is not much of a problem. Now quantitative variables can be further divided into two types, discrete variable and continuous variable. Before I define any kind of variable, I want to add this part, and please note it very carefully, that whenever I have a data, there is certain variable which you are studying. Whenever I want to, so let me put it this way, if I want to study a particular variable, then I collect data on it. So that variable can be a nominal variable, which I have already discussed, ordinal variable, or it can be discrete variable or continuous variable. If it is any kind of variable that you are studying, we can notionally denote this variable by any capital English alphabet letter, say capital X, capital Y, capital Z, and so on. And then we can just do the analysis or interpretation based on this further on. Quantitative variables can be further divided into two types, discrete variables and continuous variables. Discrete variables are the variables which assume only a set of distinct values. In fact, these set of distinct values are integer values. Let me illustrate it through an example. Suppose we give a student a experiment to toss 20 coins together, and what the student is supposed to do, count the total number of heads that appear in the 20 tosses of a coin. Then here I will represent capital X as the variable which denotes the total number of heads obtained in 20 tosses of a coin. Next comes, what kind of values can this variable capital X assume? This is the most important part. If you can understand this part clearly, you will never have problem in understanding the type of variable that you are dealing with. So here the capital X, the notionally I have said that is capital X variable. Capital X variable will assume value 0 if there are no heads in 20 tosses. It will assume value 1 when there is one head in 20 tosses, and it will assume value 20 if all of them are heads in 20 tosses. So I can clearly see that capital X is the variable, a discrete variable that is assuming values 0, 1, 2 up to so on 20. But what I want to say is that here it is not necessary that we always end up to certain point. Suppose I am looking at the total number of car accidents in a day in Delhi. Then the total number of car accidents, and again I denote that by say capital X, or let me use another variable name. Variable name can be any name that you choose. I will choose capital Y as the variable name. So capital Y is a discrete variable that indicates the total number of accidents happening on a day in Delhi. Now this capital Y, what values is it going to take? It is going to take value 0 if there are no accidents happening. It will take value 1 if there is one accident which happens. Will take value 2 if there are 2 accidents happen, and so on so forth, 100 if there are 100 accidents happen. Now here you can clearly see I cannot put any maximum limit. I cannot say okay the city will have only 1000 accidents, because this accidents happen is a random event. There is no control, anybody has no any control over how many accidents will happen. So then how am I going to write the values of this capital Y? So I am going to write capital Y is equal to 0, 1, 2, 3 and so on. That means you just put the dots, 3, 4 dots after that, which means that it can take any value starting from 0. So this is very important. Whenever we are studying the variable, first give a variable name, indicate what that variable name means, and then look at the values that this variable assumes. So once you can see the type of values that the variable is assuming, you can very quickly classify that as a discrete variable or a continuous variable. The next category or next type of variables, that quantitative variables, is the continuous variable. Now continuous variables are the variables which can take any value between the two given values. So again let me illustrate with an example. For example, capital X is a variable which denotes the weight of an individual. Now understand that when we measure the weight, then weight can be 20 kgs, 25 kgs, 21.1 kgs, 24.5 kgs, 29.75 kgs, 30 kgs, 40 kgs, 80 kgs. So 80.5, 20.95, 60, 16.75. Here I cannot associate any integer value which this variable is going to take, but I know that this variable is going to assume positive values. That means it is going to assume any value which is strictly more than 0. So and then here your capital X, the variable will assume values as capital X strictly greater than 0. Similarly, when I am trying to predict the millimeter of rainfall that I am having in a day, then again that will also be, there is no rainfall, then the value can become 0, and if there are some rainfall, then it will be some positive value. So, and these positive values can be in decimals, number involving decimals, and therefore they will always be in certain range, and here the range can be, if you think of the range, it can be going from 0 up to infinity. Once we have understood what is a discrete variable and what are the continuous variables, next comes the point that there is a data. So what happens is you have a variable under interest. So suppose your variable is the weights of the students that you have. Suppose you have weights of 50 students, and then you wonder what to do with this data, because after all, when you write the data, when you write the weights of 50 students in front of you, they look like lots of numbers in front of you, and you cannot make any head or tail about it. But now statistics is going to help you, rather descriptive statistics is going to help you to describe this data. That is the word descriptive statistics. Describe the data effectively so that you can actually analyze it. You can also use it for interpretations, and you can use it for predictions also in many cases. Now, in order to do that, what we do is we have to consider the frequency distribution of a variable. So please be very clear, frequency distribution of a variable, we will talk about under two heads: frequency distribution of a discrete variable and frequency distribution of a continuous variable. So that means we will first discuss discrete frequency distribution, and second we will discuss continuous frequency distribution. Now what we here basically we are aiming to look at how the frequencies are distributed over the different values of the variable. Consider an example where we have the data on 63 students, and we ask them how many total number of study hours they are giving in a week to prepare for a test. So we ask 63 students, they write their responses, and then I obtain the data which is given by, we can see like 5, 4, 4, 4, 5, 5, 5, 6, 6 and so on. So now we can clearly, when we look at these observations, these are 63 observations mind you, when we look at these 63 observations, we can clearly see there are certain values which are coming across. 4 is coming, 5 is coming, 6 is coming, 7 is coming and 8 is coming. So now first I will define a variable properly looking at the problem. So my variable under study, we will denote it by capital X. Here capital X is the variable that we are going to, which is under study, and it denotes the total number of study hours devoted by a student in a week for a test. So for instance, if I again look at the data, first student is devoting 5 hours, next second student is devoting 4 hours, another student is devoting again 4 hours. So like that the data has been collected. So these are the 63 observations on capital X variable, but looking all over it, capital X is assuming 4, 5, 6, 7, 8, these 5 values it is assuming. So, and not only that, we can clearly see from the data that 4 is coming 10 times. So look at the data again. So there is 4 4s in the beginning, then there are again 4 4s, and then there are 2 4s at the end. So total there are 10 4s that are occurring in this data. So a number of times a particular observation on capital X is repeated, we call it a frequency. So if we look at the values that this random variable is assuming, and if you look at what are the total number of times each of these values is repeated, which we call the frequency, then we obtain what is called a discrete frequency table. So, discrete frequency table will look like this. It will have two columns. First will be the number of study hours, which I am notionally denoting by capital X, and the other one is frequency, which gives the number of times a particular observation on capital X is repeating. So, here you can see, as I told you, by looking at the data we realized that there are 5 values, 4, 5, 6, 7, 8, and 4 is repeated 10 times, 5 is repeated 10 times, and 8 is repeated up to so on, 8 is repeated 5 times. These frequencies, when you add them up, they should become 63. That means that all the observations have been taken into account. If it is less than 63, you have missed some observation in finding the frequency. If it is more than 63, you have doubly counted a particular observation. Symbolically, we can denote it by capital Xi / Fi, where I is going from 1 to 5. That means x1, x2, x3, x4, x5, there are 5 values that X is assuming, and f1, f2, f3, f4, f5 are the 5 frequency values that you obtain. So, x1 is 4, f1 is 10, x2 is 5, f2 is 10, and x5 is 8 and f5 is 5. So, that is what we will do to construct this frequency table very properly, and then we will proceed with the graphic representation of this discrete frequency distribution